right? We get a minus because we're integrating sine. All right, what do we got? 1/4 e to the 3x sine of 4x. All right, minus 3/4, keep my parentheses. And I'm supposed to do u2 v2, which is minus 1/4 e to the 3x cosine of 4x. All right, and then minus the integral of v2, which is minus 1/4 cosine of 4x, du2, which was 3 e to the 3x dx. Again, we have 1, 2, 3 minus signs multiplied together. All right. So let me clean this up. We have 1/4 e to the 3x sine of 4x plus 3/16 e to the 3x cosine of 4x. And then it looks like a minus 3/16 integral. Oh, wait a minute, I got a 3 and a 3. See? Otherwise known as 9. So 9/16 integral of cosine of 4x times e to the 3x dx. Let me simplify this just a little bit more. I could factor out the 1/4 and the e to the 3x, and that would leave me with a sine of 4x plus 3/4 cosine 4x, yeah? So I can do that. And, you know, just to, we'll use that. Oh, be quiet. I'll tell you what, there's no more surefire way to get your kids to bring your phone to you than to make that the alert noise. They always think it's like, you know, I don't know what, my brother sent me a message. I don't know what it means. But anyway, I have 2 brothers, actually, I should mention. One does math. The other one, relative to my math classes, doesn't exist. I equals to that, which isn't to say he doesn't exist. It's just to say, you know, he's not going to email me about math, so it's not going to come up in my classes, you know. So some people are like, you have 2 brothers? I'm like, yes, I have 2 brothers. It's true. My little brother's Andrew. My also little brother is Bill. Andrew's the littler of the little brothers. So anyway, I is equal to this stuff, minus 9/16 I. All right? Therefore, the integral of e to the 3x cosine of 4x dx is equal to, what's 1 plus 9/16? 25/16 I. So what we've got is we've got like 25/16 I equals to stuff, right? So that means that the answer is 16/25 times the stuff. The stuff was 1/4 e to the 3x sine 4x plus 3/4 cosine 4x, plus a constant. I've done this much. Let me do one more simplification. We have 4/25 e to the 3x times the sine of 4x plus 3/4 cosine of 4x plus a constant. And there you go. This is a pretty standard problem if you took a survey of 10 Calculus 2 tests which cover this material, you'd find this problem on at least 7 of them. Any questions? Yeah. Right. So this right here is the stuff. So we add 9/16 I to both sides. So here, I is also known as 16 over 16 times I. So if I add 9 over 16 plus 16 over 16, it gives me 25I over 16. And all of that's equal to this. So it's the same thing as over here. It's just now we had a fraction. Yeah. All right, so let me get the projector out here for a second. All right, so these are my notes. Chapter 9, integration techniques, all right? And so what we've done today is just look at section 9.1. Now, I did not look at the examples in here. There may be some overlapping examples. I just made them up today as we went. But, you know, there's a derivation in here. Here's x sine x. Did we do that one? We might have. I think so. This right here, suppose instead of using v, used v tilde, where v was plus a constant. Like, we always are integrating dv to get v. What would happen if you added a constant? Well, if you added a constant, it would give you that extra piece, which would end up doing what? It would actually end up giving you a plus a cu from the uv piece and a minus c integral of du from the other piece, and they just cancel out. So that's why we don't have to add a constant when we integrate dv. It wouldn't change anything. It would always just end up canceling out, which is why we don't bother. All right. I have more examples. Example 3, here's x times 2 to the x. You know, you can look at that one. Here's integration by parts twice with sine. We did e to the x, but this is kind of the same example, except x squared multiplies sine instead of e to the x. Integral of inverse sine. Oop, well, that's this one. It's a rerun. Ooh, inverse hyperbolic cosine. Very similar to my example 4. Integral of log, we did that one. Sine of log, did we do that one? Oh, we did that one. I'm a creature of habit. Let's see here. This one's a little bit different. Oh, and sine squared. So this example is kind of cute. You can actually do the integral of sine squared by integration by parts that loops back where it started. But we have a better way of doing that integral without doing loopy integration by parts, right? Because we can just trade sine squared for 1/2 of 1 minus cosine 2x. That's a much easier way to integrate sine squared. We'll come back to that next week, all right? Anyway, I don't want to go through all of this. I just wanted to alert you to the fact that you should be looking at section 9.1 to try to complement what we're doing in here, okay? This is the closest thing to a required text in here that I have. It's these notes. Now, so my question to you would be, do you have any questions about your homework? Because we have a couple minutes. I might be able to give you a hint about something. We're in calculus 2, right? Oh, so she's asking me about the format. You could use line paper. You could use blank printer paper, written neatly. You could use that horrible, hideous light green engineering paper that some of you love. I hate that paper. you're a glutton for punishment, you could use the graph paper where you have the lines that are kind of like, I don't know how anybody can work on that, but you have many choices. I do, the secretary has printed for me your names in nice big font. I need to take those and tape those on some folders. I'm going to pass those out probably Monday. So you can put your homework in there. You don't have to staple it. You just have to put it in order in there, and I'll collect them that way. Because I don't think you'll be able to fit a staple through all your homework. It may be too thick, yeah.
Pencil's fine.
Oh yeah, pencil's fine. Right. That would be helpful if you boxed the answer in a different color. That wouldn't be bad. Not required, but I do want you to, if it's a problem that has an answer, right? Some problems are like derive something, then the whole thing is the answer. I mean, the whole thing is always the answer, but sometimes there's an answer to be boxed. If there is, then boxing it. Or circle. I had a chemistry professor once who took a point off a quiz of mine, and I was like, isn't this the right answer? He's like, yes, but I said to check it, and I had put an X. I didn't put a check. I put an X on the box. I was like, are you real? Yeah, he was real. Why would you do that to a... I don't know. You probably have the same feeling about some of the points I'll take off for notation. All right, but anyway. Any questions about a particular thing here? I have some good news. Well, it's mixed news. I won't be here tomorrow. So you don't have to be here tomorrow. I've already preloaded an announcement in Blackboard. It will send you a link to a previous lecture I gave on integration by parts. So if you want to see me work more examples, you can watch. There's like another hour of, there may be some duplication. I haven't been careful to not do those examples. And I'll be back, of course, Monday, and you can ask me more homework questions then. Yep.
So, I just have a question on...
Did I top hat yet? Yeah, I did. Oh, I said the word. I'm sorry. Yes.
On number 6, it says find the position, velocity, and acceleration. Is that like at a certain point, or is that just like...
As a function of time.
Oh, as a function.
Yeah, so position, velocity, acceleration, these will all be vector functions of time. So it'd be like something a function of time, comma, something a function of time, brackets.
That's the light, and it's kind of like, the light is like...
Oh.
Where the light is mounted is I think the position, right?
Okay.
Yeah. Yep. Uh-huh. Is there what? Oh, I mean, if there's a graphing, I'd like you to like print out from Desmos or whatever, or draw it, but you're fine. If you have questions, come ask me individually, as it's impossible to address you corporately now.
So I
Let me go turn off the camera before I...